discussed some of the problems on equivalent impedance of a single phase transformers. Coming to the problem number 1, a 220 by 110 volts 50 Hz 1.5 kVA transformer. So this is E1 and 110 is E2. The frequency is 50 Hz and the rating is 1.5 kVA. Transformer has primary and secondary winding resistance is R1 is 1 ohm and R2 is 2 ohms. So R1 is 1 ohm and the R2 is 2 ohms. So see, for this problem, as we discussed so many times, high voltage winding has high resistance. So that's why this is E2 and this one is E1. Okay, high voltage winding has high resistance, low voltage winding has low resistance. While reactances of this is 3 ohms, right? Let's say this is called the X1 and X2 is 5 ohms. Find the total resistance, equivalent reactance and equivalent impedance referred to primary and secondary. So this is 110 volts by 220 volts transformer. The R1 which is given is 1 ohm, R2 is 2 ohms and X1 is 3 ohms and X2 is 5 ohms. And where K is the transformation ratio, E2 divided by E1, that is 220 divided by 110, that is equal to 2. Once again listen, this problem you have to analyze. A 220 by 110 volts transformer, but here the secondary winding resistance is given as 2 ohms, which is more than that of the primary winding resistance. That's why E2 should be taken as 220, E1 should be taken as 110. So the total resistance when referred to primary, R1 plus R2 dash, R1 plus R2 by K square. What is the R1? The R1 value is 1 and R2 value is 2 divided by 2 square, 1 plus 1 by 2, that should be equal to 1.5 ohms. And X01 is equal to X1 plus X2 dash, X1 plus X2 by K square. X1 is 3 ohms and X2 is 5 divided by 2 square, 3 plus 5 divided by 4. So what is the answer? Is 5 divided by 4 plus 3. 5 divided by 4 is 1.25. So that is 4.25 ohms. Then Z01 is equal to R01 plus J times of X01, 1.5 plus J times of 425. So apply this. What is the magnitude of this? Means 1.5 square plus 4.25 square. Then you can apply root. Finally I got it as 4.5 ohms. This is the magnitude of the Z1. So this is the magnitude of the Z01. And R02 is equal to this total resistance when referred to primary. This is total leakage reactance when referred to primary. This is the total impedance when referred to primary. So this is the total resistance when referred to secondary. R2 plus K square times of R1. What is the R2 value is 2 plus K square is 2 square into R1. R1 is 1. 2 plus 4, that should be equal to 6 ohms. And X02 is equal to X2 plus K square times of X1. X2 value is 5 plus 2 whole square into 3. X1 is 3 now. 4 into 3, 12, 12 plus 5, 17 ohms. Then total impedance when referred to secondary R02 plus JX02, 6 plus J 17. So if you want to find out the magnitude, root of 6 square plus 17 square, so this is magnitude is 18.027 ohms. Okay, so this is called the magnitude of Z02. Coming to the next problem, a 6600 by 400 volt single phase transformer has a primary resistance of 2.5 ohms and secondary resistance of 0.01 ohms. See, it's a very simple. As a primary side, you should observe the resistance R1 is greater than R2. R1 is greater than R2. R1 is equal to 2.5 ohms and R2 is equal to 0.01 ohms. E1 is equal to 6600 volts and E2 is equal to 400 volts. So what is the K value? Transformation ratio is E2 by E1, that is 400 divided by 6600. 400 divided by 6600, that should be equal to 0.0606. This transformation ratio 0.0606 whole square, 0.01 divided by answer plus 2.5. So your answer is 5.22 ohms, and the R02 is equal to R2 plus K square times of R1. R2, what is the value of R2? 0.01 plus K square is 0.0606 whole square into R1 is 2.5. 0.01 plus 0.0606 whole square into 2.5. So then finally I got 0.019 ohms. So this is the total resistance when referred to primary. Total resistance when referred to primary. This one is total resistance when referred to secondary. Total resistance when referred to secondary. So coming to the next problem, a 5 kVA 440 by 220 volts. So S is equal to 5 kVA. So 5 into 10 to the power of 3 volt ampere. 440 by 220 volts transformer. R1 is 3.45 and R2 is 0.09. So this is R1 is greater than R2. So that's why it is called the E1 and this one is E2. E1 is 440 and E2 is 220 volts and R1 is 3.45, R2 is 0.09 ohms, X1 is 0.2 ohms and X2 is 0.015 ohms. He is asking what is R01, what is R02, total resistance when referred to primary and secondary, and X01 and X02 is asking, and one more equivalent impedance Z01 and Z02. So all are the unknown values. It's a very simple. R01 is equal to R1 plus R2 dash, R1 plus R2 by K square, where K is the transformation ratio, E2 by E1 220 by 440, that should be equal to 1 by 2.5. So R1 is 3.45 plus R2 is 0.09 divided by 0.5 whole square. So using calc you can solve 0.09 0.5 square. Then I got it as 3.81 ohms. And in this R02 is asking R2 plus R1 dash, R2 plus K square times of R1. What is R2? 0.09. What is the K square? Where K square is 0.5 whole square into R1 is 3.45. 0.09 plus 0.5 square into 3.45. So 0.9545 ohms. And x01 is equal to x1 plus x2 dash, x1 plus x2 by k square. This is the total leakage reactance when referred to primary. What is x1 now? x1 is 0.2 plus 0.015 divided by 0.5 whole square is equal to 0.2 plus, I am solving in calc, 0.015 0.5 whole square. Then I got it as 0.26 ohms. x02 is equal to x2 plus x1 dash. What is x2 plus x1 dash? 0.015 plus k square x1. The formula is 0.5 square into 0.2. 0.015 plus 0.5 square into 0.2. Then I got it as 0.065 ohms. Then Z01 is equal to R01 plus JX01. So 3.81 plus J.26 ohms. And similarly, so this is 3.81 plus J.6 ohm, 0.26 ohms. Z02 is equal to R02 plus J times of X02. This is the total impedance when referred to secondary. So plus J.065. What is the R02 value? The R02 value is 0.9545 ohms. You can find the magnitude and as well as the angle. So Z01 angle also you can find out. So here also you can find the magnitude and the angle. 10 minutes of imaginary part by real part. Thank you.